Okay, the fifth video on economic growth. We're still on the Solow model. This is the third video on the Solow model, isn't it? We did the basics with Cobb-Douglas and so on. Then we looked at how the model actually works and the effect of different savings rates, which was very small. And now we're going to see what happens in this model when productivity grows exogenously, which we'll let it do, is typical for the neoclassical model. Yep, which don't even remember from the assumptions of the neoclassical model. We let technology grow exogenously. So, and this is important for the course. We're going to use this quite a bit later, the techniques here. Okay. So before we talked about a steady state of the model, now we're going to talk about a balanced growth path. Okay. A BGP, which stands for balanced growth path. So we've got the Cobb-Douglas function, and now we've got a constant growth rate of productivity. I'm just going to call it G here. We've got a constant growth rate of population as well, apparently. And now, because we've got growth, often with growth, it's easier in continuous time. It's kind of neater when you've got these things growing at constant rates. Continuous time is really nice. So we've gone over to continuous time. So now we've got K dot is Sy minus delta K, which I asked you to work out earlier, but whatever. The K dot, dk by dt, the new extra K after one period of time, but in continuous time, is equal to the amount of K that was saved minus the amount that depreciated. Okay, so K dot is the change in K, it's the extra K. The equivalent in discrete time is Kt plus 1 minus Kt. Okay, that's the nearest equivalent to K dot. Okay, right. And then we want to focus on what happens in a balanced growth path. So we can be out of balance now because we've got dynamics in the model. Let me try and dig up one of my old pictures. Yeah, here's the old picture. For a given state of AL, there's a certain amount of capital in this box that means we're in balanced growth. If there's too little capital, then the capital is going to be growing faster than AL is growing, given the constant saving rate and so on. If there's too much capital, the decay of capital will be over too fast and the K will be declining relative to AL. On the balanced growth path, K will be growing at the same rate as AL. Okay. And we define a balanced growth path in general. We define it. Definition, BGP, this is slightly simplified definition. It's not always strictly true, but I think throughout the course this is good enough. Okay, all state variables grow at constant rates. That is the definition of a BGP. If you're on a BGP, balanced growth path, all the state variables are growing at constant rates, which could be zero, they could be negative, okay, but they're constant. So if we're on a BGP, K dot over K, that's the growth rate of K, is constant. But from this, if we divide through by K, that tells us that Sy over K must also be constant, or Sy over K minus delta must be constant. But if delta, we know delta is constant, so sy over k must be constant. So actually, y over k must be constant. But from here, what is y over k is ALL to the 1 minus alpha to the 1 minus alpha, k to the alpha minus 1. It's this, right? Okay. So if y over k is constant, then ALL over k to the 1 minus alpha must be constant. And L, well, yeah, that tells us. So if ALL over k is constant, that tells us that AL dot over AL plus L dot over L equals k dot over k. So that must hold on a balanced growth path. How to explain that? There's different ways of explaining that. Let's say that, like, I don't want to use C. Let's say D, where D is some constant, is equal to this. Then we can bring the K up and we can say dk equals AL L. Well, now actually I think I'm going to save this for another video. At the moment I'm just going to say that if this is constant, then this must be growing at the same rate as this. The growth rate of this is just k dot over k. This is like percent. The growth rate of this is AL dot over AL. The growth rate of this is L dot over L. And the growth rate of the product is just the sum of the growth rates. If this is growing at 1% a year and this is growing at 2% a year, then the product must be growing at 3% a year. Okay. So, what does this tell us? I think I'm just going to pause the video here and collect my thoughts. If I can just find the pause button. Okay, I think we're recording again. Hope I got this right. The next question is, so we've worked out this equation, AL dot over AL plus L dot over L is k dot over k. But what we're really interested in is y dot over y, where y, little y, is defined as big Y over L. Widgets per year per worker. Okay. If Y is big Y over L, Y dot is, well, I'm just going to tell you this for now, and then we're going to go through this. I'm going to go through this in a separate video. But y dot over y is big Y dot over big Y minus big L dot over big L. Okay. I'm going to explain this in a separate video. I think it's better. Right. This is a lot more convoluted than I thought it was going to be. Because now we need to work out y dot over y. Yeah, I really do need to explain this. Never mind. So we've got little y dot over little y is big Y dot over big Y minus L dot over L. L dot over L is just N, but what is big Y dot over big Y? It turns out, based on this, big Y dot over big Y is 1 minus alpha AL dot over AL plus L dot over L plus alpha K dot over K. Okay? But K dot over K is the same as AL dot over AL plus L dot over L, which is this. So Y dot over Y is just AL dot over AL plus L dot over L. Oh, sorry, that was big Y dot over big Y, and then minus N. Minus N, it's just AL dot over AL. Okay, I'm not totally happy with this video, but never mind, I'm gonna sort it out with a second one. But what we've shown is that GDP growth per capita is just on the balanced growth path, it's equal to the growth in productivity. Okay, so this is absolutely crucial. GDP grows at the growth rate of productivity, and we see this quite nicely in the data. This is a sort of test, not a real test, but a bit of a test of the model where we take data from Germany around the time of the Second World War, where Germany seemed to be roughly on a growth path coming up to the Second World War. Then there was a huge loss of capital around in the 1944, 1945. The economy was smashed to smithereens, and GDP fell when capital fell drastically. But then over the following 20 years, the economy went back to its old growth path with a growth rate, a growth trend. Oh, I haven't written down. Yeah, 2.3% per year growth trend. So the model does a reasonably good job, apparently, of explaining how a single economy on its own, with trend growth, which we can't explain, how it reacts to a shock to capital. Okay, but it doesn't explain the trend growth except to say that it's thanks to technological change, and it doesn't explain the differences between countries. Okay, and there's some things that we'll talk about in when we meet. So I want you to think about those before we meet. And I'm going to stop this video here, and then there'll be a super short one about Ramsey.